Imagine you are in a spaceship in space. From nowhere, a black hole consumes the Earth. As the Earth passes the point of no return, a question arises. Is the Earth stuck there forever? Or would it come back? If so, would it be the same? In order to answer that question, we must know what a black hole is. A black hole is simply a black hole. No, this isn't a black hole. This is an artistic impression of a black hole. It is a very dense celestial object that is formed when stars die. It has such a huge amount of gravitational force that even light cannot evade it. To understand this better, we can do this activity. Imagine that this piece of cloth is the fabric of space-time. That is, the intertwining of the three dimensions with time. For better representation, I'm going to place it over an open container. Now, any object with mass would create a dent or warp the space-time. This warping of space-time is the effect of gravity. Now, a black hole is so dense, it will infinitely warp the space-time. Over here, there will be a point on the space-time where if any object would pass over, even if it was accelerated to the speed of light, it would not be able to come out. This is called the point of no return, or the event horizon. Stephen Hawking theorized and proved that black holes emit matter as high-frequency radiation, conveniently called as Hawking radiation. Here, a question arises. Is the Hawking radiation in any way related to an object that has fallen into the black hole? Or is the object completely destroyed? This is the black hole information paradox. Another major drawback in this situation is that we have not been able to observe black holes or their emitted radiation properly. Now, you must be thinking, why information paradox? This is because when an object falls into a black hole, it is sure to get converted into another energy form due to such high density. But all the states of all the atoms of this object may get stored as quantum information. Well, there are only three possibilities that could happen to this quantum information. It could either get stored in the black hole, or it may get emitted out as Hawking radiation, or it may even get destroyed altogether. Let's move on to the first possibility that black holes emit information. There is a published theory that states this exact same thing. So if black holes do emit the information, then there may be a way to observe all the matter absorbed by black holes that were emitted out as Hawking radiation. So if all the correlations between the Hawking radiation are properly observed and studied, we might have an idea on what a black hole had for dinner. Let's move on to the next possibility, that black holes destroy information. This is the easy way out of the paradox, but sadly, most physicists rejected this possibility as black holes cannot destroy matter but can only convert them. Even if the information was converted by the black hole, it still would not have been destroyed. There is one theory revolving around the possibility that black holes store information. It says that the black holes will store the information until it dies. Now the great question, how do black holes die? As I said, black holes emit Hawking radiation. So when they stop absorbing matter, all their mass will be emitted out as Hawking radiation. So when the black hole dies, the information may be emitted out as Hawking radiation. An easy way to understand this is to look at the clouds in the sky. The clouds keep getting bigger and bigger until they finally release some water as rain. In this case, black holes may not actually be able to have remnants, as black hole remnants are very unstable. The main theory that is at the front line against this paradox is a theory that has been put forward by Stephen Hawking himself. This theory states that black holes might have quantum hairs. Well, this doesn't mean that black holes have hair like us, but these hairs are meant to say that black holes might have detectable parts. So quantum hairs might mean that black holes have parts which we can detect at the small quantum level. For this, it is said that black holes leak information into the periphery of its event horizon. This periphery is theorized to be comprised of soft photons and gravitons. Photon is a name given to light as a particle, and gravitons are theoretical particles that transmit gravitational waves. But what are soft photons and soft gravitons? Well, as the name says, these particles are soft and have much less energy than other photons and gravitons, and may not be able to be detected well. So, the information may leak out into this cloud of photons and gravitons, but we may not know if all this information leaks out into this cloud, or maybe there are no quantum hairs at all. So, to answer the first question at the beginning of this video, that what will happen to the Earth if it goes into a black hole? Well, the answer is, we still don't know. With sufficient technology, we may be able to obtain the quantum information of the Earth, and we may even be able to reconstruct it back. Who knows? Maybe you can find out.